Hi, my name is Greg Van Norman,
I'm Josh Cernical.
I'm Cassandra Ryan.
I'm Mark Ante.
and this is our senior technical project, the pneumatic flip-top 2000 assembly machine.
For our project, we're going to be designing and building a machine that will assist in the assembly of the flip-top 2000, which is a spray cap for a defense aerosol can, such as pepper spray. The Avanti company currently assembles these caps and will be funding the project. After completion of the project, they are going to take the machine and use it in the production of the flip tops. The Avanti company is owned and operated by Greg's family, so he has been designated the project manager and will be doing all the interfacing between us and the company with regards to the project. The final product will be a machine that is capable of greatly increasing the productivity and the efficiency with which the flip-top 2000 can be assembled. Along with the machine, the company is going to receive all the detailed mechanical drawings and everything that they could need or would need if they want to have more of the machines made in the future to further increase their productivity.
Avanti is my family's company. My grandfather is the CEO and my father is the COO. We are currently the distribution center for America and Canada and a little bit of Israel. We currently distribute key rings, quick releases, and self-defense sprays, the caps and cases for them. Most of the assembly for these components is done out of house and outsourced to local family members, but the parts that are needed to be done quickly and shipped out as soon as possible are done in-house. There are currently about 15 employees in-house and 50 out of house, but everything right now is done by hand. There's little to no streamline efficiency to all these assemblies that we currently do. MSB Industries is the injection molding company that we currently use as our provider for all of these plastic parts. They make all of their machines, molds, and casts in-house up there. They currently have a prototype of this assembly machine for the flip-top model 1000. There are very distinctive differences between these two, between the 1000 and the 2000. We are currently working with Brian Villarino, the head engineer of MSB Industries, and he is helping us reverse engineer and recreate this machine to better streamline the productivity here in New York.
So to kick off our project, we created a Gantt chart. This Gantt chart shows the summary, tasks, and milestones of our project. To begin with, two of our members visited MSB Industries. This was Josh and Greg. They visited with the head engineer to determine what was needed for the project and how he created the prototype model 1000. From there, they also obtained pictures of the model and a working video of how it operates. The next phase of our project was the research phase, which we all conducted. We all researched previous senior projects to determine what was needed for our project and manufacturers that MSB Industry uses. These manufacturers would be the ones providing our pneumatic components, because MSB Industry has a select few manufacturers that supply them. From there, we went into the reverse engineering phase. This includes the calculations and the designing of the circuitry with Visio. The Visio components would be designed by Greg and Josh, while me and Mark will be doing the calculations for the project. From here, we will go into recreating the design, the new design for the Model 2000. This will include any changes from the Model 2000 from the 1000 prototype to better increase their productivity. After this, we should hope to have obtained the materials in between the 2 semesters. Therefore, by the time next semester starts, we should be able to build and test design. The build and test design is where we will actually build our prototype of the Model 2000 machine that will be handed to the company. After this phase, we will be able to optimize it to make sure the machine is working correctly and properly before it's handed off and before our final presentation.
The main purpose why we chose this project and why we decided to stick with just the pneumatics is because right now there is a prototype and it is working. And we noticed that, and I've been working for Avanti for the past 7 years, and not much has changed. I wanted to streamline this assembly. And since the Flip Top Model 2000 is the latest, greatest out there for the pepper spray, and it's only being done by hand, and the machine up in Canada at MSB is only the 1000, I decided to choose this as the senior project to better help out my family business.
Now, we've been hearing a lot about the Flip Top 1000 and the Flip Top 2000, but what exactly are the differences? Why do we need to make a brand new machine for this? Well, part of the reason is the design. Right on the screen here, you can see right on the left is the Flip Top 1000, on the right is the Flip Top 2000. Both are CAD drawings made by Greg. And on the 1000, you can see there are ridges on the side and it's hollow on the collar. On the newer version, the 2000, there are no ridges on the side, giving it a smooth, sleeker feel, and the ridges are on the collar.
There is also a pin in the bottom of the Flip Top 2000 that is absent in the bottom of the Flip Top 1000. This can tell police or law enforcement or whoever that this pepper spray has been fired or used. This can help in investigations or help out local law enforcement.
The word productivity has been floated around a couple of times in this presentation. So why is productivity so important? Well, the main reason is the increased demand. During the early stages of this project, Avanti picked up 2 brand new clients, one being Walmart and the other being Amazon.com. Pretty familiar names, just to give you some idea of the companies. Both are on the Fortune 500 list. On the 2000 list, Fortune.com stated that Walmart was ranked number 1, and Amazon.com was not that far behind, ranked at number 12. So both of these distributors sell a lot of pepper spray and have such a high volume of product that they need. So designing it by hand, simply, they just cannot keep up with it. So you need a machine that increases the productivity. This machine is 100% pneumatics. The only electrical part is the power that's supplied into the air compressor. In the control box, it may look like a little bit of a mess, so it was brought up to us, why not use a PLC, a programmable logic controller? Well, the whole team here discussed it. Ideally, it sounds like a great idea, but the biggest thing, the problem that we ran into when we discussed it with Brian at MSB is the fact that the employees at MSB are the ones that operate the machine, and they do not have anyone in-house that knows how to run the electrical or the PLC. So if a problem were to occur, no one knows how to solve it. They would have to hire a specialist to come in there and fix it. And the problem that that means is there's a lot of downtime. And once again, as we stressed, we need a high productivity because Walmart and Amazon.com and other companies really want these, and we really need to get these out fast.
So this is a working video of our project as soon as it begins. You can see cylinder B is right here. This one will extend the rack, causing the gear to turn, as you can see. And cylinder C right next to it is actually threaded into that gear rack, and that will pull the cylinder back to reset the process.
Cylinder A, as you can see right here, that pushes the pin inside the collar.
And once cylinder A is fired and C and B push the rack into the cylinder X, cylinder X acts as a cushion, and in cylinder A here there is a spring that when the pin is pushed in, there's a little bit of back force on it. So when the pin is rotated, there's a little J hook that locks it into the flip top. This little nudge there is what locks the J into the hook.
After everything's been located inside the top of the flip top and cylinder C is retracted out of it, cylinder D on the end comes down and press fits the bottom of the flip top to the top, completing the process.
So what we're changing on this from the prototype 1000 to the 2000 model is we are creating a new nest for the 2000 flip top. This is because the ridges have changed, so there needs to be a new nest to hold it in place. On top of this, the collar holding the bottom portion of the cap is also going to need to be redone, just so it can effectively hold it in place long enough to compress the two components together. From there, we will also be changing the mounting styles of the cylinders. We will be screwing them down to make sure that they stay in place effectively, and we'll be changing the sliding brackets. On top of this, if time allows, we'll be including an ejection cylinder. This cylinder will eject the component off the collar. And then
To start the design process, Greg and Josh traveled to the MSB plant in Canada where they were able to meet with the head engineer. While there, they were able to see the machine firsthand. They were able to see how the system operates all together and how each of the different components interact with one another. They were also able to obtain a video of the machine working that you just saw, and also a lot of pictures that we have been able to use as a reference through the whole design process. Another big thing that came out of the meeting was that they were able to let both companies know what our project was, what we planned on doing, and make sure that everybody was on board with what we were doing. To start the design of the machine, we started by looking at the control systems. There's a lot of different components, as you can probably kind of get an idea in the Visio sketch. They have to all work together, so by determining how all the airlines are connected and what needs to be where and what needs to do what, that was a huge undertaking, was the first thing we did for our project. The next thing we looked at was doing the mechanical drawings for all the parts that need to be custom made for the machine. There's a number of parts that you can't just go pick up at the local hardware store that are going to have to be manufactured. So designing those and getting an idea of what we're going to have to do to manufacture them in the spring was the next thing we wanted to look at. And after that, we started to specify what the cylinders would have to be to do the task at hand, and along with that, kind of looking at, what pressure and flow and all the system specifications that we would have to have for our system to operate properly. After we did all that, we were able to come up with a pretty complete bill of materials, and from that bill of materials, calculate a fairly accurate cost for the project that we could then go and compare with the projected cost savings from having the machine increasing productivity.
So for our design process for the calculations portions, we will be mainly pulling from fluid power control systems and aspects from MSD to determine the gear, rack, and pinion. And then we'll also be using calculus and physics to determine different forces that are acting on the frame. The main calculation we'll be using for almost all the cylinders is force equals area times pressure. This calculation allows us to determine the exact force that's needed in each individual cylinder from the operating pressure. From there, we'll be able to determine the flow rate required for each cylinder, and this is going to greatly be determined by the time needed for each individual cylinders. And then from here, we will be able to use the flow to spec out the compressor needed to operate the machine. And then the torque for cylinder A that you saw earlier will be needed to determine the amount angle of rotation that is needed to put the pin and hook it into the J-hook. After that, the frame will mainly have bolt calculations from every single cylinder and the amount of thread contacts that will be needed into the base to determine how thick it should be.
These are some of the Visio drawings that I drew up. If you're following along on the PowerPoint presentation that we submitted with it, these 6 control valves here are the main heart of this machine. They are 5-port, 2-position air solenoid control valves, and there are 6 of them. There are 4 gauges that tell you the pressures for each, and 4 pressure regulator valves on each of those gauges. These gauges here will let the user know if there is a problem, and if there is, follow the lines to the problem, and it'll be a quick fix. That means less downtime for the company. There are hundreds of components in here, and at the top there's the timer, the 6 control valves, the gauges, the regulators, and there's a whole bunch more. If you want to see more, you can look into the bill of materials that we will have later. Next, these are the cylinders and the push-button control valves that we have. Cylinder A, as you can see, can slide forward and rotate, and cylinder B and C are the ones pushing. Cylinder X is the cushion, and cylinder D is the one that compresses the collar into the flip top. All of these drawings will be, or all of this machine will be running off of 2 paddle control valves that once both of them are pressed, they will effectively launch the machine, but only if both of them are pressed at the same time.
So what are the outcomes of this project? The outcomes is to basically increase productivity and supply the manufacturer with a way to remodel, with a way to remanufacture the machine, and to improve it in case they ever have a different model like they do now. So from this machine, we should be able to, in theory, increase productivity by 181%. This means they'll be able to make numerous amount of flip tops than they've been previously doing, because they've been doing them by hand. On top of this, they should have a 64% reduction in time. This means that production will go a lot faster, and they'll be able to get the products out a lot faster. So based off, these calculations were based off 10 parts that were assembled by hand versus the prototype that's currently in the Canada facility. And that's our presentation. Thank you for watching.